Example 2 of finding the domain of a sum, difference, and product of two functions. In number 2, we are given these two non-rational functions here, so immediately we can tell that since they don't have any denominator, they don't have any part of continuity, so the domain of both of these functions are all real numbers, hence from negative infinity to positive infinity, open interval. So let's find the sum of these two functions. So f plus g is equals to 5 minus x squared plus x squared plus 4x minus 12, which is equals to, these two cancel out, and 5 minus 12 is going to be negative 7, so 4x minus 7. The difference is f minus g equal to 5 minus x squared, and then minus, put the g function inside the parentheses, because it is mandatory. Since there's an invisible negative 1 on the front, distributing this negative 1 to each term on the inside, we are going to have 5 minus x squared, and then minus x squared again, minus 4x, and then plus 12. Combining like terms again, we are going to have, let's see, x squared minus x squared is going to be negative 2x squared, and then bring down to minus 4x. 5 plus 12 is going to be 17, so plus 17. And I don't think we can factor this out, so we are good on this. F times g will be 5 minus x squared multiplying x squared plus 4x minus 12. Distributing the 5 minus x squared to each term inside this, we are going to have 5 minus x squared times x squared plus 5 minus x squared times 4x, and then plus 5 minus x squared times negative 12. Well, distributing this x squared, we are going to have 5x squared minus x to the 4th. Distributing this 4x into the 5 minus x squared, we are going to have plus 20x minus 4x cubed. Distributing this minus 12 into 5 minus x squared, we are going to have minus 60, and then plus 12x squared. Simplifying a little more by combining like terms, we keep the negative x to the 4th. We also keeping the negative 4x to the 3rd. We are combining like terms of 5x squared and the 12x squared, which is going to be 17x squared. So yeah, keeping the 20x and keeping the minus 60. And I'm not going to try to factor this because it's so long. Now let's find the domain of sum. Well, the domain of the sum, if we take a look at the sum, it is a function with no denominator, as well as every step of the simplification process right here. This step also has no denominator either, so we don't have any restriction for this sum of the two functions. So because of no restriction in f and no restriction in g, and because the domains of both f and g are all real numbers, and because also there's no restriction in the result of the in the sum of f and g, the domain of the sum is also all real number. Now looking at the difference and looking at every step of finding difference, we have no restriction as well. So that means the domain of f minus g is also all real number. And of course, looking at the products of f and g, it doesn't have any denominator, so no restriction in the result. And in every step of finding the product right here, no restriction either. So that means the domain of f times g is also all real number. Like that. Okay, how does it look on a number line? Well, just like in example 1, my number line here, sketch that, negative infinity to positive infinity. the function f has the domain of all real numbers, so from negative infinity to positive infinity. The function g also has the domain of all real numbers, like that. So the domain of the sum is the set of all of the common x value that both domains have, and those common x values, or all of the x values from negative infinity to positive infinity. So that's why the domain of the sums are the same. And the same reasoning apply to the domain of the difference and the domain of the products. And since I'm out of marker here, I'm just going to use this, the red one, for the product as well. So yeah, graphically, that is how we understand this.